Welcome to my channel Just to Know. Our today's topic is on classification of acid-base disorder. This question could be asked as a 3-mark question or as a part of an essay question on acid-base disorder. Introduction. The physiology of the human cell is designed to function at a narrow range of pH around 7.4. Any drastical change in the pH can result in the disturbance in the normal metabolic homeostasis. Hence, life is not possible above the pH 7.6 and below 7. But there are certain causes which alters the pH by decreasing the plasma pH or increasing the plasma pH. If the cause is decreasing the plasma pH which brings below 7.4, then the condition is called as acidemia. Or if the causes increases the plasma pH above 7.4, then the condition is called as alkalemia. The clinical disorder associated with the acidemia and alkalemia are called as acidosis and alkalosis correspondingly. Here, the clinical disorder acidosis is associated with the accumulation of acid in the tissue or plasma, and alkalosis, it is associated with the building up of alkali in the body. In simple, remember, in acidosis, acid will be accumulated and base will be lost, and in alkalosis, base, the alkali, will be accumulated and the acid is lost. The accumulation of acid or base in the body can result due to the two main reasons. One is associated with the metabolism, that is due to the metabolic overproduction, and second is associated with the respiratory, which is due to the failure of the respiratory system to eliminate them. Now let us see the further classification of acid-base imbalance. Acidosis, the fall in pH, which is further classified into metabolic acidosis. Remember, a condition characterized by primary bicarbonate deficiency. Then respiratory acidosis, a condition characterized by primary excess of carbonic acid. As a diagnostic part, in metabolic acidosis, the bicarbonate level is less than 22 millimoles per liter. And in respiratory acidosis, the PCO2, the partial pressure of carbon dioxide, is greater than 45 mmHg. In detail about these disorder will be seen in the upcoming videos. So please do subscribe our channel for more updates and suggest your interested topic in the comment section which you want us to post. Alkalosis, the rise in pH, which is further classified into metabolic alkalosis, the condition characterized by primary excess of bicarbonate level. Then respiratory alkalosis, the condition characterized by primary defect in the carbonic acid. In diagnostic part, in contrast to the acidosis, metabolic alkalosis, the bicarbonate level is greater than 33 millimoles per liter, and in respiratory alkalosis, the partial pressure of CO2 is less than 35 mmHg. Compensatory response. Whenever the blood pH, the 7.35 to 7.45, tend to become low or high, adaptive changes are brought into action which brings the pH towards the normal. This adaptive changes in the concentration of the compound is known as compensation. All kind of acid-base imbalance are characterized by a change in either of the two compounds, the carbonic acid or the bicarbonate. So, the proportional change in the other compound would help in maintaining the ratio constant and hence will bring back the pH to the normal. Stages of compensation. There are 3 stages of compensation. Stage 1, uncompensated. In this stage, the defect is identified and the compensation mechanism is started. Stage 2, partially compensated. In this stage, the various compensation mechanism takes place. Stage 3, fully compensated. In this stage, the compensation mechanism is stopped and the normal pH is attained. Now, we see the two compensation mechanism. If the problem lies in the metabolism, which is primarily due to the change in the bicarbonate level, then the metabolic compensation is done by the respiratory system. First one, in metabolic acidosis, there will be hyperventilation. Why? The reason is, in acidosis, there will be bicarbonate deficiency which is compensated by decreasing the carbonic acid level by stimulating the respiratory system, where the respiration becomes deeper and faster, thus pushing out the CO2 and bringing back the ratio to the normal. Then, on the other hand, in metabolic alkalosis, there will be hypoventilation resulting in retention of CO2, thus increasing the pCO2 and providing the compensatory restoration of the ratio. Second type for the respiratory compensation. If the problem is in the respiratory system, then the renal mechanism can bring the compensatory response. In respiratory acidosis, which is due to the retention of CO2, there will be an immediate compensatory elevation of bicarbonate by the kidney by excreting the excess H plus ion and retaining the bicarbonate to bring the ratio to the normal. Then, in respiratory alkalosis, the kidney provides the compensation by decreasing the bicarbonate level to retain the ratio. General causes of disturbance in acid-base balance include any serious illness, multiple organ failure, respiratory failure, cardiac failure, uncontrolled diabetes mellitus, and poisoning such as by barbiturates. Steps in clinical assessment of acid-base disturbance starts with the assessment of pH, serum bicarbonate level, atrial pCO2, check the compensatory response. Remember, pH less than 7.4 is acidosis and pH greater than 7.4 is alkalosis, which is followed by assessing the anion gap and finally the assessment of underlying causes.